notation? Yes, exclamation point is a mathematical notation. So this isn't n. That's not what it means. It's not that we're really excited to see n. We call this n factorial. N factorial. So the exclamation point is called a factorial. All it is a shorthand notation because if you haven't figured out yet, mathematicians, we're pretty lazy people. We don't like words because there's too many things to write. We like things to be really, really simple. So this is a way to simplify something. If I give you 5 factorial, and again, that's not 5, it's called 5 factorial. What it means is 5 times 4 times 3 times, anyone want to guess? 2 times 1. How many times on Thursday did you write 5 times 4 times 3 times 2 times 1? That's what the factorial is for. It's just because we're really lazy. So instead of writing all the way out 5, 4, 3, 2, 1, we just write 5 factorial done. What do you think 8 factorial means? 8 times, 7 times, 6 times 5 times 4 times 3 times 2 times 1. Again, just a shorthand because we're lazy people. Why the exclamation point? Well, apparently, when this notation came around, they looked at the keyboard and said, what hasn't been assigned yet? Ooh, exclamation point. And they made it a math symbol. That's where it comes from. So I was actually giggling on Tuesday, Jordan, at the very end when you're like, I'm going to put an exclamation point. I'm like, can't even tell you. What does n factorial mean if we break it down? Well, it starts with what you have, which is n. So 5 factorial started with 5, 8 factorial started with 8. So we're starting with n. How do I get the next number? So how did I get 7 or 4? Minus 1. So then I have n minus 1. How would I get the next number? N minus 2. And we say dot, dot, dot until we get down to 1. Here's the ones you have to memorize. Anything bigger than that would usually be a calc question or there'll be a way to simplify it. So 2 factorial, you know, is now 2 times 1. 2 factorial equals? Not a trick question. 2, yay! 3 factorial would be 3 times 2 times 1. So 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1. So 4 times 3 times 2 times 1, 24. 5 factorial, so 5 times 4 times 3 times 2 times 1. So 5 times 4 times 3 times 2 times 1. 120 it is. Again, anything bigger than 5 would either be a calc question or there's going to be a way to simplify it. What about 0 factorial? This is one of these little rules at the beginning that makes no sense in math. 0 factorial. It's actually 1. Yeah, you think it should be 0, but it's not. And I'll tell you why when we get down to where we actually use this, why it's like that. How to find it on your calc if you've got the old operating system. Ooh, can you see the screen? Better? No light? Oh, not better. So let's say we want to do, I don't know, 8 factorial from above. You put the number first, so I'm going to type in 8. I'm going to go into the math menu. And I want to go over to what's called the PRB menu. It stands for probability. So you can either tab all the way to the right. I just tab to the left and wrap around. And then what do you see in that list? Number 4, factorial. Hit enter, 40,320. Okay, so jot down whatever you need in the box to remember that. Math menu, tab right or left, whatever your preference is, to the probability menu, PRB. And then number 4. The sole purpose of the factorial notation is just shorthand, so we don't have to write out all the digits all the way down to 1. So first thing we're going to do is simplifying some factorials, and then we'll do some kind of regular permutations examples. So first one wants us to simplify 10 factorial divided by 8 factorial. This would be a non-calc question, and you're like, what? But I thought I didn't have to know these. No, I'm going to show you the quick way to simplify these without having to know 10 times 9 times 8 all the way down. So the trick with these is you want to take whatever is the bigger factorial, and you want to start what I call breaking it down. So which is the bigger number, a 10 factorial or an 8 factorial? It's going to be 10 factorial. So I'm going to start doing what I call breaking down. And I'm going to just say, well, I know 10 factorial is 10 times 9 times, and I'm going to stop there. I know it's the same thing as 10 times 9 times 8 factorial. Why did I choose to stop at the 8? Because that's what's on the bottom, and we can cancel them. What's 10 times 9? 90. Don't look at the board. Don't let the math scare you. Don't do it. You don't even know what it is yet. Question so far on A. If you're a wordy person, take the bigger factorial, the bigger number, and break it down. Take the bigger factorial and break it down. So if I gave you 12 factorial over 10 factorial, again, calculator question, no big deal, punch that in your calc, get the number. But this would be a multiple choice or a 1-mark non-calculator question. And the directions say simplify, so we're trying to make this simpler. Which one is the bigger number, 12 or 10? 12, so let's break it down. Starts with 12 times, and that's where I want to stop. Why do I want to stop at 10? Because it cancels with the bottom. 12 times 11. Well, what about these crazy questions where they give you n? So now we don't have real numbers. We've just got these stupid variables. Process is still going to be the same. You're going to figure out which is the bigger one, and you're going to break it down. To figure out the bigger one, just pick a number for n. Give me any number. 3. Which is going to be bigger, 3 or 3 minus 2? 3 is going to be bigger, so it's telling you the top is going to be bigger. So you can pick any number, 8, for example. You'd have 8 on the top, you'd have 6 on the bottom. So 8 is going to be bigger. So we're going to start breaking down n factorial. So n factorial starts with an n, and then is n minus 1, and then n minus 2, and I'm going to stop there, factorial. Why did I choose to stop there? Because it cancels on the bottom. And then it's just a distribution, so n times n times negative 1, n times n, and then n times negative 1, negative n. Okay, so process is still the same. Figure out what the bigger one is, break it down. N factorial over n plus 1 factorial. Again, if you're not sure which is bigger, pick a number. 14. What's going to be bigger, 14 or 14 plus 1? The 14 plus 1. So it's the bottom this time we're going to break down. What do we do when it starts with an n plus 1 factorial? Well, it just starts with what it is, n plus 1. Then times. Now, in theory, we're going to have n plus 1 minus 1. And I wouldn't normally write that out. I would jump straight to what n plus 1 minus 1 is, which would just be n, and that's where I'm choosing to stop. Why am I choosing to stop there? Because that's what the top is. So the n factorial on the bottom and the n factorial on the top are going to cancel. Now, classic mistake here, people want to put n plus 1. The answer is not n plus 1. Why not? Kind of. What happens when you cancel? So what's 6 divided by 6? Or 10 divided by 10? Or n divided by n? So there's a 1 on the top, n plus 1 on the bottom. So just note your brain just wants to put n plus 1, but you just have to realize it's on the bottom, not on the top. Example number 2, let's go back to our normal kind of permutation questions. Jeff has 5 different favorite songs. How many different playlists can he make, assuming that the order matters to him? How many blanks am I going to draw? 5. How many choices of song for the first one? 5. Then. So this is all we put. If you want to write it all out, then do that. It's just we're kind of lazy and we don't want to have to do that. It was so hard for me to teach you last Tuesday and not write a factorial because I never write all the way down to 1 just because I'm lazy. So it's really hard when you know factorials to not do it. You now have memorized 2, 3, 4, 5, and 0 factorial. So you know 5 factorial is 120. Okay, so that's the only difference we're changing the questions now is we just have a notation to shorten it up. Let's do a restriction question. How many 4-digit numbers can be made using the numbers 3, 6, 8, and 9 if repetition is not allowed? Keywords in the question. 4-digit numbers, I would highlight or circle that. Anything else in there you think is important? 3, 6, 8, 9. And repetition not allowed. How many blanks would you like to put? Is there any conditions on the blank? So any greater than this or less than that or has to be this or has to start with that? Nope, only restriction is we can't repeat. So how many choices for the first? 4, because we have the 3, 6, 8, and 9. How many choices for the next one? And then, so all I'm going to put is 4 factorial. And we've now memorized 4 factorial is 24. Again, just repeating, the point of permutations is to answer questions like this without having to write out all 24 possibilities, because it's easy to miss one, it's easy to double count one. The purpose of our notation today is just to make this faster. How are we doing so far? Good. What? There's a formula? We call this formula NPR, or sometimes you'll hear me say NPICR, because we tend to use pick because we're picking objects. You'll see when we do combinations, there's a formula for that one too. So NPR or NPICR. And N and R are always subscript numbers, so they're little tiny numbers. N is the number of objects that we have. R is the number we want to choose. And the NPR formula is equal to n factorial on the top divided by n minus r factorial on the bottom. This is why we need the factorial notation before we could do the formula. Otherwise, the formula would make no sense to you at all. N factorial over n minus r factorial. Is it on your formula sheet, or do you need to memorize it? Dig it out, prove it, check it. It's on the sheet. Tell me where, left-hand side or right-hand side? Top, middle, bottom? Middle-ish? Okay, so it is on there. You can already peek and see the combination formula that might be coming in a while. Okay, so how does this change things up? Well, we're going to do the exact same question the old way, and then we'll do it by the new way, and then you can pick whichever way you like better. You don't have to use the formula if you like the blanks. You don't have to use the blanks if you like the formula. So in how many ways can 3 people, oh, we're back to people sitting. 3 people sit in 5 desks. And I'm going to split my page, and we'll do the FCP first. And then we'll do the new way with the formula. What does FCP stand for? High five to you, fundamental counting principle. That's the blanks. So we have 5 desks, 3 people. Am I drawing 5 blanks or 3 blanks? 3 blanks. Why? Because it's the lower number. How many people could choose the first desk? No, let me say it backwards. How many desks does the first person have a choice of? And then followed by? And then followed by? Now, I didn't use a factorial this time. Why not? So why didn't I just put 5 factorial? Because it doesn't go all the way down to 1. Okay, so unless you're doing the number all the way down to 1, you can't use a factorial. So this is just a straight up multiplication. So 5 times 4 times 3, 60. Okay, 60 different ways with 3 people and 5 desks. We're going to do the exact same question with the new formula. So we have 5 desks, and we want to pick 3 of them. So on the top, I have 5 factorial. On the bottom, I have 5 minus 3 factorial. To simplify, we do brackets first, just like we would do in any equation. So 5 factorial stays on the top. On the bottom, 5 minus 3, 2 factorial. This is why we just practice simplifying factorials, is because we use it in a question like this. We're going to break down the higher one and then stop when we get to the lower one. Which one is higher, 5 or 2? Okay, so let's start breaking it down. 5 times 4 times 3 times 2 factorial. And why did I stop at the 2? Because I want the 2 to go from the bottom. And so just take a look what we had here. Take a look what we have here when we cancel. So total has to be 60. Completely up to you which way you choose to do the question. I usually use blanks, but sometimes if I get lazy, I'll do the formula. The formula is also on your calculator. So let's punch in a 5 pick 3 just to make sure it works. The way it works in your calc is you put the n value first, so the 5. You go back into the math menu, go to the probability menu. What do you see in there? Number 2. And then I'm going to punch in the, was it 3? Yep, 3. Now if you've got the new operating system, it'll actually do nice little subscripts for you. And we should get 60. So I would never do this by hand unless it was a non-calc question. Typically when I'm using the P formula, it's for really big values, like we have 20 things and we want 12 of them, and I'm like, bah, I don't want to draw out 12 blanks and I don't want to have to fill in 12 different numbers. That's when I would grab the formula. I would just do a 20 pick 12, for example. Write down whatever you need in that box to remember where it is on your calculator. So something about the math menu, something about the probability menu, something about number 2 and pick R. We'll take a look at example 5, 6, and 7. What the heck are these? Well, in math, if you haven't noticed, we love solving equations. We started way back in grade 7. We were like, linear equations, yay, move everything to one side, collect all the like terms, divide by stuff. And then grade 11, we were like, whoa, quadratic, right? That was pretty scary. How many ways were there to solve a quadratic, by the way? There were 5. What are the 5 ways to solve a quadratic? Yes. Come on, you know this, you know this, you know this. Square root, yes. A little bit louder. Calculator, graphing, yes. Glance up at the wall. Anything look familiar over there? Quadratic formula, and the last way was completing the square. Kind of remember that from last year? So anyways, we're like, quadratic, 5 different ways to solve, and you were like, bah! And now we get to grade 12, and we're going to start adding in all kinds of different equations you haven't seen yet. So these ones are called factorial equations. Oh yeah, I forgot we added in cubics. Remember that in polynomials? Cubics and quartics and quintics. Yeah, we added those in. What's coming later are trigonometric equations, which we kind of showed you last year a little bit. That'll come in the next unit. Then we'll do logarithmic equations, which you've never seen before. And you're like, why? Why do we need to solve equations? Because they make us happy. And really, because we can. That's why we solve stuff. And what if nobody ever wanted to solve anything? Well, then we'd just write poems and talk about history. So really, it's math and science people that we really care about stuff. So why do we do factorial equations? Because they're fun and they're cool. So very basic equation. We'll start with number 5. If this was a calculator question, we could guess and check. We could just plug in numbers and figure it out in our calculator. I don't know, 4p2, figure out what that is, 5p2, figure out what that is, 6p2. But mathematicians don't really like guess and check unless we have to, because what if the numbers are really, really big? What if I gave you 100p2? Well, your calculator sometimes can't even do super big factorials. So I'm going to show you the algebraic method on a smaller one where it's easy to guess and check, so that when you get to the harder ones, you're not just still stuck plugging into your calculator. So this one I understand. We can easily just figure it out, but let's do it the long way. Step number 1 is we have an equation for NPR. So that's what we're going to do is sub in the other side of the equation. NPR says at the top is n factorial, and the bottom is n minus r. So in this case, it's n minus 2 factorial. So step number 1, if you're a steppy person, would be substitute into the formula. Substitute into the formula. Well, this is why we just practice the simplifying with factorials when there's n in it, was for this. So step number 2 is going to be simplify the factorials. Step number 2, simplify the factorials. I'm so not a morning person. Simplify the factorials. So figure out which one is bigger. Again, if you're not sure, just put in a number for n. What's going to be bigger, n or n minus 2? N. So it's n factorial I'm going to start to break down. So it starts with n, then times, n minus 1, then times, n minus 2. Stop, make him the factorial. Why did I stop at the n minus 2? Because he cancels with the bottom. If you didn't notice, that's already example 1c. That's why we did it before. Multiply it through n times n, and n times negative 1. Step number 3 is solve for n. Step number 3, solve for n. What kind of equation is it? What kind of equation? It's quadratic. That's why we just reviewed the 5 ways to solve a quadratic. Which method would you like to use? Yeah, But what if it's a non-calculator question? We're kind of screwed. I'd like to factor. So I'm going to bring it all onto one side. I heard a really quiet negative 6 and 5. Split and solve. But we just need to keep in mind, what do n and r mean? So in the permutation formula, what is n? The number of objects we have. Could we have negative 5 objects? No. So the very last step is reject the extraneous roots. Reject the extraneous roots. What's an extraneous root? Yeah, one that doesn't work in the given formula. So we're just going to make a note that n has to be greater than or equal to 0. N has to be greater than or equal to 0. Can't be negative. Here's why 0 factorial is 1. If you have 0 objects, in how many ways can you arrange them? If you have 0 objects, in how many ways can you arrange them? 1, 0 ways. Here's my 0 objects. There's the ways I've arranged them, 1 way. That's why it can't be 0, otherwise this whole formula is going to fall apart. I know it's kind of philosophical. How many ways can you arrange no objects? Questions so far on the factorial notation, or factorial equations? They're always going to work this way. You're going to substitute into the formula, you're going to simplify, you're going to solve for n, and then look for anything that's negative and kick it out. So NP3 equals 60. Oh, I don't. Is it Mr. Radley? Is it Mr. JR? Oh, Mr. Hayes, going to give me a thumbs up through the window? Is he still there? Yeah. He gives me a thumbs up when he's taking a bathroom break so that I can just like listen out for his class. So now you know, every time he thumbs up, it's going to the bathroom. Or really going to get coffee. But. Okay, following the exact same steps, what's going to be first? Substitute into the equation. So an NP3 would be an n factorial over n minus 3 factorial. Step number 2, simplify. So figure out which is the bigger one, and let's break it down. Okay, so n times n minus 1 times. Should I stop there? Why not? That's where I stopped above. Why wouldn't I stop there here? I did that up there. What's going on? I don't want to stop until it cancels, so I'm going to stop after the n minus 3 factorial. Got to simplify this mess. What do I do with it? It already is factored. Yeah, and it doesn't matter the order you distribute. My brain grabs the binomials first, and then I multiply by n. Some people like to do the first two. It doesn't matter. I'm going to FOIL the brackets first because it's just what my brain sees. So an n times n would be an n times negative 2, and a negative 1 times n, and a negative 1 times negative 2. Again, you could have multiplied the n by n minus 1 first, doesn't matter. And then I'm going to distribute this all the way through. Shoosh, shoosh. N times n squared. N times negative 2n. N times negative n. And an n times plus 2. And then I'm going to bring the 60 over in the same step because I know eventually I need the other side equal to 0. And then what's the very last step? Yeah, just collect those like terms. So I have a negative 2n and a negative 1n, which gives us negative 3n squared plus 2n minus 60 equals 0. Step number 3. Solve for n. How do we solve a cubic? We can't because of the 60. If we could, that would be nice. Yeah, it's something with that division thing. Anybody else remember anything about that? Polynomials? Solving quartics, quintics, cubics? Synthetic division. There's a step before the synthetic division, though. How do we know what to divide by? Remember, this is that one guess and check that we do, and we try to find a number that when we put it in here gives us 0. I know, I don't like cubics either. Don't shoot the messenger. Okay, so go ahead, guess and check. It's probably not going to be 1. There's a hint with a 60. Probably not. Somebody else confirm that 5 works? Sure doesn't really sound confirmed. Sounds more like just agreement. Okay, what do we do now that we found one of them? Yes, good job. Synthetic division, 5 on the outside. What numbers are going to go in here? Mm-hmm. 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 Notice how every unit kind of ties into the next unit? So we did this way back in polynomials, but it's coming back. Drop the 5. Yep. Oh, we just add. Yeah. And why is that 0 so important here? It's a check, right? Because we know that it has to equal 0. So now we're down to x squared plus 2x plus 12. Do what some more? We've done a lot of stuff. You should be a politician. You always go for the most generic answer, the safest answer. It's quadratic. How many ways are there to solve a quadratic? 5. Let's try to factor. Factors of 12. 1 and 12. Can those make 2? 2 and 6. 3 and 4. What does that tell us? It's not factorable. It doesn't mean there's not a solution. We could find it with quadratic formula. However, we know they're not going to be whole numbers. We're going to end up with some kind of radical in the quadratic formula. What does that mean in terms of n? Well, let's go back. What does n represent? How many objects we have. Could we have some decimal value of an object? No. So it tells you that n not only has to be greater than 0, but n has to be. And what's the symbol for whole number? Element of. It has to be wholes. What's the symbol for wholes? W. That doesn't say new, not to a mathematician. That's n is an element of the whole numbers. So what it tells us is that we found the only whole number over here. N has to be 5. Again, it doesn't mean this isn't solvable. We could get some decimal values by using quad formula, but for this equation, we can't have decimals. So n has to be 5. So what it means when you get a cubic, you get to stop after you found the one that gives you 0. There's no point of going on and doing this synthetic division, so this stuff here isn't necessary for this kind of equation. How are we feeling so far? Sideways? I'll take a sideways thumb right now. Let's step it up even further. Let's look at number 7. There's a lot going on in 7. Same steps as the last two. Even if I've got this 2n in there, still going to follow what I know. Step number 1 is substitute into the formula. So I'm just leaving that 2n because I don't know what to do with them for now, so I'll just leave them in front. Let's switch out the NPR. What's on the other side? N factorial, n minus 2 factorial. Step number 2, simplify. So I'm still going to leave that 2n in the front. I'm not going to worry about him. He's just hanging out there. Which one am I going to break down, an n or an n minus 2? An n. So it's going to be n times. Yep. Times. Stop factorial. So I still have that 2n in the front. I'm just not even looking at him, not worrying about him. I just need to multiply here, so n times n. And then n times negative 1. And I'm going to bring this 56 over at the same time so that everything's on one side. And here's the first time that 2n comes into play. I'm just going to simplify him with my negative n. So I've got n squared plus n minus 56 equals 0. Quadratic! Look how often quadratics come up in these guys. I heard now for plus 8 minus 7. What's the very last step? Look for any extraneous roots. Which one of these is not possible? Negative 8. Last one is one of those explanation questions. So explain why 3 pick 8 cannot be calculated. Just turn and talk to someone. Kind of two different ways you could describe it. Most went method 1, which is fine. I overheard your discussions. Most people said, well, if you've got 3 objects, you can't pick 8. That's a fair discussion. You can also talk in terms of the formula. If we were to put this into the formula, what would we end up with? So 3 pick 8 would be 3 factorial on the top and negative 5 factorial on the bottom. Is that possible? No. So you can also talk about a factorial not being able to be negative. However you choose to describe is up to you. So whatever makes sense, write down a sentence. Okay, so if you have 3 objects, you can't pick 8, or you can't have a negative factorial. Negative 5 on the bottom, right? You can't. Why would it? Because it's 3 minus 8. Your brain's somehow flipping that N and that R. Right? After your explanation, I just want to add the third condition on the formula, is that n has to be greater than or equal to r. So n has to be greater than 0, as does r. N has to be an integer of the whole numbers, as does r. But n also has to be greater than or equal to r.